Yes, students, all of you, welcome to the session.
Good evening.
Yes, thank you. Good evening. Is it audio is clear?
Yes, sir.
Thank you. With respect to power electronics subject, I completed one is fundamentals and types of power semiconductor devices. The second chapter is single phase rectifiers. Three phase rectifiers at the end and I will give. Now I am going to starting one more important chapter for any competitive exam point of view, choppers. That is the DC to DC converters. Okay. In DC to DC converters, first we have to start with some introduction. In general, there is a two types of choppers. One is AC link chopper, another one is DC chopper. Before developing the DC choppers or choppers, to convert fixed DC into variable DC. To convert fixed DC into variable DC, we are used AC link choppers. What do you mean by AC link chopper? This is fixed DC and this is the control DC or variable DC. In AC link chopper, you have to convert DC to AC by using inverter. Again, you convert AC to DC by using rectifier. This combination is nothing but AC link chopper. Fixed DC to variable DC or control DC. But what are the drawbacks of AC link chopper, friends? There is a two-stage conversion. You have to convert DC to AC. Again, you have to convert AC to DC. Because of two-stage conversion losses are increases. Efficiency reduces. That is one drawback. One more drawback is it requires two converters. Inverter is one converter, rectifier is. That is, it requires more number of converters, which increases size and cost of the equipment. And it occupies more space. All these are the drawbacks. No doubt at all, using this configuration, we can convert fixed DC to variable DC. Okay. But what are the drawbacks of AC link chopper? What are the drawbacks? Because of two-stage conversion, conversion losses are increases. Conversion losses increases. Any doubt? Is any problem? Conversion losses increases. Efficiency decreases. The efficiency decreases. That is one drawback. One more drawback is because of more number of converters. More number of converters. Yes. What about the cost increases? And it occupies more space. It occupies more space. Then to overcome these drawbacks, you have to make fixed DC to variable DC in single stage conversion. Only in one conversion only, we have to make fixed DC to variable DC. We have to get fixed DC to variable DC. That's why DC choppers are developed. These are called DC link choppers. Generally, DC link chopper means chopper. Chopper is nothing but a DC chopper only. If it is given AC link chopper, then only you take the AC link chopper. Chopper is a DC chopper only. A chopper is a static device that converts fixed DC to variable DC. This is fixed DC. This is variable DC or control DC. Variable or control DC in single stage conversion. It is basically high speed on off semiconductor switch. A chopper is nothing but on and off, on off, chopper on, chopper off, chopper on, chopper. That's why it is basically on off semiconductor switch. This is very important. 5-star statement for competitive exam, already question is there. It may be thought of a DC equivalent of AC transformer because they behave an identical manner of transformer. But the identical manner of transformer, by using these choppers, we can step down the DC voltage or step up the DC voltage. Just like in a transformer, we can step up the AC, step down the AC. Like that, using choppers also, we have to step up and step down. That's why it's a DC equivalent of AC transformers. It is a DC equivalent of an AC transformer. Just like a transformer, AC transformer, by using the choppers, we can step up and step down the voltage. Chopper is a static device that converts fixed DC to variable DC, but single stage conversion. This is important here. In a single stage conversion, directly you can convert fixed to variable DC. Okay, this was the definition of the choppers. What are the types of choppers? Based on output voltage level, the choppers are classified into buck regulator. It is also called step down chopper. Boost regulator. It is also called step up chopper. Buck boost regulator is also called up down chopper. Shook regulator. But this is not there in syllabus. Most of all the competitive exams, either GATE or ESC or any PSU's point of view, these three choppers important with respect to output voltage level. Buck regulator, boost regulator, buck boost regulator. That is up down choppers. Clear. This is
No,
based
sir.
on output voltage. Yes.
Sir, go to the first slide, sir.
This one.
No, sir, the previous one.
This one.
Sir, one doubt, sir. In this, the rectifier block, the symbol before the diode, like 3, it is a winding or what, sir?
This one.
The red color, sir.
Yeah, this is the transformer. Just like
Okay, sir. Okay, sir.
we are supplied through transformer. Like this. Okay.
Yes, sir.
It may be rectifier. It actually it's a diode, or we can use the thyristor also. Okay. It's a controlled means you have to use the thyristor. Okay.
Yes, sir.
Next, based on the quadrant operation, the choppers are classified into this is the second classification of choppers. Type A chopper. In some textbook they taken class A. Type or class both are same. Type B chopper or class B chopper. Type C chopper or class C chopper. Type D chopper or class D chopper. Type E chopper or class E chopper. But point you have to remember, students, this topic, these three choppers, important for GATE, ESC, PSUs. for your state government jobs point of view. So these three choppers, step down, step up down choppers. This is important for all these citizens. But these choppers are, this topic is important, very important for ESC and PSUs. But for GATE, less importance. That less important for the GATE one. All the competitive exam, it is important, but ESC and PSU's point of view, this topic is important. Based on this topic, the questions are asking quadrant operation. Type A chopper is operating in which quadrant, type B is in which quadrant, type C in which quadrant, like that. That type of questions are important for PSUs. Okay. This is the second classification. The third classification of choppers is based on type of commutation we are using. Voltage commutated chopper, current commutated chopper, load commutated chopper, zone chopper, Morgan chopper, and AC chopper. AC chopper, why the name is AC chopper, later I will explain. This is based on commutation. But this topic is very important. This topic is ESC point of view. Even for PSU's point of view also it is. But in GATE syllabus it is not there. Only commutation methods are there in GATE syllabus. But types of choppers based on commutation is not there in GATE syllabus. But ESC and PSU's point of view it is. This multi-phase choppers, only one time it is asked in GATE exam. Only one time it is asked in GATE exam for multi-phase choppers. These are the different types of choppers. But very, very important, once we are preparing for your PSU's point of view, this is 5-star concept and this also 5-star concept. But this choppers is not there even though in GATE syllabus. But briefly I have to give some important points. Then first I am starting the types of choppers. I am going to starting types of choppers based on types of choppers. Choppers based on output voltage level. Based on output voltage level. But one point to remember, students, as compared to devices and rectifiers, solving of the questions in choppers and inverters is very easy. Why? Because most of the questions in choppers and inverters, direct formula based questions. But there is some formulas will come. You have to practice that formulas 2 or 3 times. Then directly from the formulas, you can easily solve the problems. Types of choppers based on output voltage level. In that first I am starting operation and analysis of buck regulator is also called step down chopper. Operation and analysis of buck regulator or step down chopper. First, we'll see what is the step down chopper. This is the circuit of the step down chopper. Before starting, what is operation and analysis? Some points mainly how to remember here. That is important. Listen. Okay, this is the chopper. Here, the chopper may be just I use it as a switch only. The switch may be any device here. Every time in the problems, they don't give only switch representation. They will give any device. The switch may be MOSFET. By giving the MOSFET also, they will give the chopper. Or the switch may be IGBT, BJT, GTO. And the switch may be SCR. By giving any device, they will give the circuit. But for simplicity, simply I shown with a one switch on. But if the switch is used as a MOSFET, it is used for high frequency application. High frequency, low power. For high frequency and low power applications, we are using MOSFET. IGBT, BJT and GTO. These are used for medium power application. Medium power application. And SCR is used for high power application. No other alternative. For high power, you have to use the SCR. High power and low frequency application. And one point you have to remember, students. This I given the chopper. Na? A chopper is nothing but a DC to DC converter. Generally, this DC to DC converters are one is chopper, another one is SMPS. Switched mode power supply. Even SMPS is also DC to DC converters. Chopper is also DC to DC converter. But what the difference here? If the DC to DC converters are used for high power application, just like in motor control like that, then that is nothing but a chopper. If the same DC to DC converters are used for low power application, just like in CPU, CPU also in computers, in CPU also there is a DC to DC converter. But that is low power application, na? That is called SMPS. That is, chopper is also DC to DC converter. SMPS is also DC to DC converter. But when the DC to DC converters are said to be choppers, if it is used for high power, and when the DC to DC converters are said to be SMPS, if it is used for low power, both are DC to DC converters. Okay. Here, the switch may be any device. Based on the application, we have to use the different types of switches. But if you use MOSFET, IGBT, GTO, BJT, these are the self-commutated switches now. No need of any external commutation circuit. Why? All these are the fully controlled devices. We can turn on and turn off by gate itself. That's why if you use these devices, no need of commutation circuit. No need of commutation circuit. Because by using control signal itself, we can make on and off. But if you use SCR, commutation circuit is required. Because it's a semi-controlled device now, commutation circuit is required. This is only difference. Commutation circuit is required if you use SCR. But you have the doubt, sir. If you use SCR, it requires commutation circuit now. Then why you are going for SCR, sir? This is preferable. Yes, most of the applications we are using this one only. But in high power application, no other choice. Go for SCR only. If you see nowadays, in most of the electrical vehicles now, EVs, electrical vehicles, instead of SCRs, they are preferring GTO. They are using GTO. Why? It is a self-commutated. Means using gate itself, we can make the on. Gate itself, we can turn off. On and off is using gate because it's a fully controlled device. But in some high power applications, no other choice. Even though commutation circuit is required, we have to use the SCR. Clear? At that point, you have to remember. Okay, this is one observation. Before going to the in detail analysis, by seeing the circuit, some points you have to remember. Next. And one more point you have to remember, friends. Just by seeing the chopper, you have to identify, is it a step down chopper or step up chopper or up down chopper? Because in most of the competitive exam, simply they framing the question like this. For the chopper circuit shown in figure, what is the average output voltage? They don't mention type of chopper. Then which formula you have to apply? Then first you know what is the type of chopper. Then how to identify the chopper? Simply remember. For buck regulator or step down chopper, it is also called step down chopper. Na? For buck regulator or step down chopper. If inductor is at load side, inductor is load side or load is shunted by diode. Important. For this only two points you have to remember. Two references. You take either inductor is reference or diode is reference. Actually, you take the inductor or diode. If inductor is at load side, that is the step down chopper stress. That is buck regulator. If inductor is at source side, later on you will see that circuit. That is called step-up chopper. If the inductor is at middle like this, then it is up-down chopper. Then it is a up-down chopper. That is buck boost regulator. Like this, you have to identify. Inductor is at load side or load is shunted by diode. For buck regulator only, you take the two references, remaining only one reference. Inductor is at load side or load is shunted by diode is a buck regulator. Inductor is at source side, boost regulator, that is step-up chopper. Inductor is at middle, at the center, between load and like this, shunted, middle shunted, then it is nothing but a buck boost regulator. Like this, you have to remember. Like this, you have to identify step-up chopper, step-down chopper, and up-down chopper. And one more point you have to remember, this buck regulator step-down chopper is also called V to I converter, or it is also called V to I converter. Boost regulator or step-up chopper is also called I to V converter. It's also called I to V converter because inductor is at the source side. It is a V to I converter. It is also called I to V converter. Like this, you have to identify. That points also I'm writing more. If inductor at load side, inductor is at load side, or load is shunted by diode, load is shunted by diode, or one more reference is either inductor, either L nor switch, either L nor switch grounded. That is, inductor is not grounded, switch is also not grounded. Then it is a which regulator? Like this, identify the buck regulator. This is the buck regulator. Or how to identify step down chopper. Because most of the cases, sometimes the questions are asking for the chopper circuit shown in figure, step up chopper, step down chopper, up down chopper, like that it is asking. That you see in your TNPSC previous question. That question is asked. Up down chopper question is asked. Sorry, step down chopper question is asked just by giving the circuit. Okay, like this you identify. If inductor is at load side or load is shunted by diode, or one more reference is either inductor nor switch, either L nor switch. L stands for inductor here. Either inductor nor switch. Grounded. Inductor is not grounded, switch is not grounded. Switch is not grounded, inductor is also not grounded. Then it is nothing but a step down chopper. Then how to identify step up chopper? How to identify step up choppers? That points also I will give. Just a minute, I'm adding the slide. Next, how to identify step up chopper or boost regulator? Inductor is at a source side. Later I will give that circuit. Inductor at source side. Or switch is grounded. Switch grounded. Take any reference. This reference or this reference. Then it is a which one? Boost regulator or step up chopper? Boost regulator or step up chopper? Step up chopper. Next. Inductor is at middle. Inductor is at middle. That is between load and source. Or inductor is grounded. Inductor is grounded. Inductor is grounded. Then it is a up down chopper. Up down chopper. or it is also called buck boost regulator. Like this you have to put. Next, this you have to remember. And one more point you have to remember, friends. This every chopper we can analyze in three cases. Case one is continuous mode. Case two is continuous mode, practical case. Case three is discontinuous mode. Only for continuous mode, only in detail I will explain. Most of the cases in many exams, ESC exam, GATE exam, or PSU's exam, they are asking only continuous mode. For continuous mode practical case, I will give direct formulas. Discontinuous mode, I will give direct formulas. I don't want to give in detail derivations. Only for continuous mode only I will explain. But even though I will explain for each derivation in detail, final formulas only it is important. During your preparation, just for concept understanding point of view, I will give so many steps. But final formulas only I will give. You have to consider that summary also I will give. That for summaries you have to practice. Yes, at that point. And one more point to remember. First, in continuous mode means, even in rectifiers also I given statement. We are assuming that we are supplying the constant current to the load. Constant current to the load. With that assumption only, continuous mode is analyzed. And one more point to remember. Sir, what is the difference between the chopper and regulator? Either chopper or regulator, both analysis same, students. Even though they given the chopper, they given the regulator, analysis same. But only difference is a chopper with filter is a regulator. A chopper without filters, that is the chopper. See, for example, the same circuit I will represent like this. This is the chopper, but the circuit is represented with along with L and C. Then this is the regulator. But if the regulator is given or chopper is given, same analysis. Extra in the regulator, what we are getting? Filter, where L is the filter inductor to reduce the ripples in the load current. C is the filter capacitor to reduce the ripples in the load voltage. What is L here? Filter inductor. L is the filter inductor to reduce the ripples in the load current. L is the filter inductor to reduce ripples in load current. Ripple in load current. C is the filter capacitor. Filter capacitor to reduce ripple in load voltage. To reduce ripple in load voltage. Load voltage. Clearly, I will write. C is the filter capacitor to reduce ripple. Filter capacitor to reduce ripple in load voltage. Okay. How to calculate C and L also I will explain. Next. In analysis of choppers, there is so many theories are there to analyze these choppers. Energy balance theory, like that, so many theories are there. But I am following the volt second balance and current second balance. I have to use volt second balance. Volt second balance. Using volt second balance, according to volt second balance, VL on into T on plus VL off into T on equal to 0. Ampere second balance. These two formulas I have to use to derive the so many formulas. According to ampere second balance, IC on into T on plus IC off into T off equal to 0. IC off. By using volt second balance and ampere second balance, I will explain the so many formulas. Students, for 3 choppers, step down chopper, step up chopper, up down chopper. For each chopper, nearly you can get 15 to 16 formulas for each chopper. For total 3 choppers, you can get 40 to 45 formulas. But don't think, sir, how I remember that much number of formulas. Just practice whatever the questions I am giving, then you can easily remember. Okay. Direct formula based question. From that formulas only, if any question is asked from the choppers, directly you can explain. Okay, that point to remember. Now, first I am starting with this knowledge. First I am starting operation and analysis of buck regulator. First you will see what is the operation of the buck regulator. First I am explaining the operation of the buck regulator. But point you have to remember, students, one operation is nothing but one on and one off. Chopper on, what are the observations? Chopper off, what are the observations? Chopper on, what is the observation? Chopper off, what are the observations? Then after that, you have to derive the different formulas. Yes. What is the operation of the chopper? Buck regulator. Step down chopper. First, I am explaining for continuous mode. With the assumption of continuous mode, okay, I am explaining. Okay, this is a chopper or switch. Chopper or switch is on. Then this diode is the freewheeling diode because this diode carries the current through the load. This diode carries the current within the load. That's why it is called freewheeling diode. Chopper or switch is on. Diode is off. The diode is the freewheeling. Chopper or switch is on later for 0 less than t less than t up to t on. Up for 0 to t on and off is in our hand. Whenever you want, you can on the switch. Then whenever you want, you can off the switch. It is not a manual operation. You can write the program. But during this time switch is on, during this time switch is off. Sir, why you have to make on and off? If you make on and off the switch, then only we can convert fixed DC to variable DC. That's why we are doing the switch on and off. If switch is on, L is storing the energy. L storing the energy. Then L storing the energy, apply the KVL switch. But point to remember, during storing the energy, the polarity of inductor will one polarity. During releasing the energy, inductor reverse polarity. But even though it is reverse polarity, but for analysis purpose, we are assuming that fixed polarity. Throughout analysis, we are following the fixed polarity. We don't change the polarity. This is VL and this is V. Throughout analysis, we are following the fixed polarity. But no doubt at all, during inductor is releasing the energy, after reversing the polarity only, it releases the energy. But for analysis purpose, we are following the fixed polarity. This is plus minus VL. This is plus minus V. Okay. L storing the energy. Then inductor storing the energy, apply the KVL. This is during chopper is on. Apply the KVL. Then if you apply the KVL, what you get? Positive to negative, negative. Voltage falling, minus VL. Positive to negative, negative. Minus V naught. Negative to positive, positive. Plus Vs. Equal to 0. Then from this, what is VL equal to? VL equal to V naught minus Vs. So VL equal to Vs minus V naught. What is VL equal to? That is Vs minus V naught. This is VL on. Why I taken this is VL on? This is the voltage across the inductor during chopper is on. Na? That's why it is called VL on. This is equal to L into di by dt. Direct this formula also asking in computer exam. If the chopper is on, what is the voltage across the inductor? VL equal to Vs minus V0. But I told already, one operation is nothing but one on and one off. Okay, chopper is on. This is the next. Chopper is off. This is the first step. Chopper or switch is off. Chopper or switch is off. If chopper or switch is off, diode will on. The diode is on. If diode is on, this inductor releasing the energy through diode. Then L releasing the energy. L releasing the energy. L releasing the energy. Diode, if once the diode is on, L releasing the energy. Clear. Now, if the L is releasing the energy, now I'm drawing the equivalent. Chopper or switch is off. No? This is the equivalent I'm drawing. Now diode is on. No? Diode is on. Like this it is coming. And this is inductor. This is capacitor. And this is the load. Voltage across the load is V. Okay. And this is the diode. The supply voltage is Vs. Plus minus. This chopper or switch is off. This chopper or switch is off. But no doubt at all, during inductor is releasing the energy. This is minus, this is plus. Then this is negative now. That's why diode is forward bias. But for analysis purpose, I am following the fixed polarity. Sir, why you are taking fixed polarity, sir? Why not you changing the polarity? You have the doubt. I told already, using this concept, I am deriving the formulas. If you reverse the polarity here, students, if you reverse the polarity, then apply the KVL, then you take minus here. Then also you can get same answer. But if you don't change the polarity, then you take plus here. That's why I am following the same polarity. I am not changing polarity, plus minus here. Now apply the KVL here. Then if you apply the KVL, minus VL minus V0 equal to 0. Clear? Then from this, what is VL equal to? Minus V0. VL equal to minus V. This is VL off. Why it is a VL off? It is the voltage across the inductor during chopper is off state. That is the meaning of VL off. Voltage across the inductor during chopper is off state, students. That's why it is a VL off. Next. Next. During chopper is on, one more point. This is during chopper is off, this is chopper on. During chopper is on, you can also apply KCL. Here I applied the KVL. Na? You can also apply KCL, students. Let this is IL. Don't change the directions of current. Fixed directions. I'm following the fixed current direction. This is IL. Then during chopper is on, this IL is entering, IC and I0 is leaving. IL equal to IC plus I0. From this, what is IC equal to? IL minus I0. This is IC on. This is during chopper is on. Next. Don't change the current directions also. I am following the fixed current. No doubt at all. The current directions also will change during the operation. But for analysis, I am following the fixed directions. Here also, what is IL equal to KCL if you apply? IL equal to IC plus I0. From this, what is IC equal to? IL minus I0. This is equal to IC off. IC off. That is IL minus I0. This is current through the capacitor during off state. This is IL minus I0. Clear? Clearly you have to write. Is IC equal to IL minus I. Follow the fixed current directions, follows the fixed polarity voltage. Once you know this KVL and KCL, then you can derive any formula. Okay. Before deriving the formulas, just see some waveforms here. Listen, students. This is during chopper is on. This is T on. This is during chopper is on. This is T on. This is T on. T on is nothing but a DT. And this is T. This is during chopper is on. This is T on. We know that even in the fundamentals also I given this one. What is T on equal to D into T? What is T off equal to? 1 minus D into T. What is D here? Duty cycle. You follow any notation for duty cycle. Different authors, they are following the different notation. Delta, K, alpha. Any notation you follow, that is a duty cycle. Chopper is off. I given chopper is off now. Chopper is off for T on less than T, less than T. Between T on and T, chopper is off. This is chopper is off. This is the case of chopper is on pulse. This is off pulse. Again, chopper is on pulse. But our analysis for only one time period. We are doing analysis for one time. Now, listen. During chopper is on, what I told, inductor storing the energy. Inductor storing the energy. Chopper is on now. L storing the energy. Here L releasing the energy. Let's assume that it is a continuous mode. If it is a continuous mode, already there is a minimum current. Continuous mode means, I told so many times in the rectifiers. Wherever we are doing the continuous mode, let's assume that it is not starting. After some operations, we are drawing the waveforms. After some operations means already there is a minimum current in the inductor. Then during chopper is on, inductor storing the energy. During chopper is on, inductor storing the energy. Like this. During chopper is off, inductor releasing the energy. Again storing the energy. This is the inductor current wave. This is IL waveforms. Inductor current wave. The current is changing between minimum and maximum. Next. I am drawing the switch current waveform. This is equal to source current wave. Both are same. Can I accept that? Why switch current waveform and source current waveforms are same? The source and switch is series. The source and switch is series. That's why the switch current waveform is equal to source current waveform. Both are equal. The switch and source current waveforms are same here. Then let's assume that this also we are drawing continuous mode. When the current is passing through the switch, if the chopper is on, chopper or switch is on, then only switch current is exist now. This is the switch current. If the chopper is off, is there any switch current? No. Chopper is off, there is no current through the switch now. There is no current through the switch. Again, chopper or switch is on, the current is passing through the switch. If the chopper or switch is on, then only current is exist through the switch. Now I am asking the question, friends. If the here chopper or switch is off now, chopper or switch is off, who is the carrying the current? Diode. Then this case, which current is exist? Diode. During the conduction of diode, inductor releasing the energy now. This is the diode current wave. This is the diode current wave. And this is the switch current wave. Wherever the switch is conducting, then switch current is exist. Wherever the diode is conducting, then diode current is exist. The current is changing between minima and maxima. This is the minimum current, IL minimum. And this is IL maximum. Because the continuous mode, we are assuming that the current is changing between minima and maxima without current becomes zero. These are the inductor current waveform, switch current and source current waveform. This is the diode current waveform, students. With this knowledge, the first formula that I have to derive here, you have to find the average output voltage of buck regulator. There is so many formulas I will give. Every formula is important. Based on every formula, so many times the questions are framed in different complex. I told already, to derive the different formulas, first you have to use the volt second balance. According to old second balance, VL on into T on plus VL off into T off equal to 0, students. What is VL on you calculated? It's already calculated na KVL. According to KVL, VL on equal to Vs minus V0. What is VL off? VL off equal to minus V0. Substitute that. This is Vs minus V0. This analysis I am doing to derive the formulas into T on plus. What is VL of minus V0 into T on equal to 0. Yes, friends. What is T on? T on equal dt. Na? Just now I told already. Vs minus V0 into dt minus V0 into, this is dt, na? T into dt minus V0 into T of is 1 minus d into t equal to 0. Then Vs minus V0 into dt equal to V0 into 1 minus d into t. This dt cancel. You bring V0 this side. Vs minus V0 by V0 equal to 1 minus d by d. Divide with V0. Vs by V0 minus 1 equal to 1 by d minus 1. From this, minus 1 cancel. V0 by Vs equal to 1 by d. What is V0 equal to? What is the V0 equal to? This is correct. V0 in T of is 1 minus d. No? Then dt cancel. This d I am bringing this side. 1 by d minus 1. Vs by V0 minus 1. Sorry, Vs by V0. No? Not V0 by Vs. So Vs by V0. Then what is V0 equal to? dVs. Very, very important 5-star gunshot form. This formula you have to remember finally. Just for concept point of view, I explain all this. But don't feel, sir, why this much of derivations are this? Sir, you have to learn the subject. That is my main motive. Even though you are feeling, sir is giving more number of points, more number of, that is total subject like that. But my motive is learn the subject. If you don't want that total subject, but finally I am giving the formulas now. You take that formulas only. Whatever you want, you take. But this formula you have to remember. I am telling that every time. Statements also I'm giving. Yes, it is a gunshot formula. Then that formulas also you have to practice. No problem. But some students are interested in learning the total subject also, no? By considering all the students only that I'm giving. But some students are don't have patience. Some students are don't have any patience. For those students, mainly take the formulas only. For those students. Yes, thank you. Yeah, V not equal to dVs. Okay, this formula is important. Now, in a buck regulator or step down chopper, what is the average output voltage? dVs. Therefore, in buck regulator or step down chopper, average output voltage V not equal to average output voltage V not equal to dVs, where d is the duty cycle. Where d is the duty cycle. This formula you want to remember. But you have the doubt here, sir, why the name is given as a step down chopper? Why the name is given as a step down chopper? V not equal dVs, where d equal to duty cycle, that is T on by T. This is equal to T on into F. 1 by T is F now. That's why we can also write like this. V not equal to T on into F into Vs. This is one more formula. V not equal to T on into F into S. D equal to T on by T na, duty cycle. D equal to duty cycle. Duty cycle. Friends, what is the range of duty cycle? What is the range of duty cycle? Range of duty cycle is, in general, range of duty cycle is 0 less than D less than 1. Always in between 0 to 1 only. V not equal to dVs na? In buck regulator, that is in step down chopper. In step down chopper, V not equal to dVs. Okay. You substitute any value in between 0 to 1. Take any value. For example, for D equal to 0.7. What is V not equal to? 0.7 Vs. For D equal to 0.5. What is V not equal to? 0.5 Vs. For D equal to 0.1. What is V not equal to? 0.1 Vs. Any value in between, for any value, for any duty cycle, V naught less than Vs. Always we can get V naught less than. Hence, it is a step down chopper. Hence, it is a step down chopper. That's why it is called step down chopper or buck regulator. Any duty cycle you substitute for this formula, we are getting V naught less than Vs. Once you know the average output voltage, how to calculate average output current? Then average output current equal to output current. I naught equal to V naught by R. If it is a R load, RL load. You can also apply I naught equal to V naught minus E by R. If it is a battery load. If the battery load is present, you have to apply I naught equal to V naught minus E by R. These two formulas mainly you have to concentrate. Minimum. What is the circuit? You have to remember the circuit. How to identify the step down chopper or buck regulator. What the average voltage, average load current formula. Next. So many formulas will come, sir. But final formula is mainly important. Now you have to find what is the average current through the inductor. What is the average inductor current? To find the average current through the inductor, you have to apply ampere second balance. You have to apply ampere second balance. Sir, why? What is this volt second balance, ampere second balance? Volt second balance VL on into T on plus VL off into T off means stored energy equal to released energy. Even capacitor also, charging current equal to discharging current. That is the concept only we are applying. Then IC on into T on. What is IC on I calculated? IC on I calculated during chopper is on. During chopper is off. IC on equal to IL minus I. IC off equal to IL minus I. Both are same here. That I am substituting here. This is IC on equal to IL minus I on. IL minus I naught into T on. Plus IC off equal to IL minus I naught into T on. Equal to 0. Take IL minus I naught is common. If IL minus I naught is common, T on plus T on. T on plus T on equal to 0. Then IL minus I naught into T equal to 0. Then what is IL minus I naught equal to 0? This is very important 5-star gunshot form. Therefore, in buck regulator or step down chopper, final formulas are who are waiting for final formula. Please remember this one. In buck regulator or step down chopper, more patience is required for any competitive exams. Then only you can easily crack the exams. In buck regulator or step down chopper, then average inductor current. Average inductor current. You have to take IL average or simply you take IL. Any notation you follow. This is equal to I naught. Average inductor current equal to average load current. For example, simply the question will ask like this. In a buck regulator, average load current is 10 ampere. Then what the average inductor current? Average inductor current also 10 amperes. Average load current is 10 ampere. Then average inductor current equal to average load current, that is equal to 10 amperes. This is the second formula you have to remember. But the third formula. In the first case, I given average load voltage, average load current, and average inductor current that I use. That you have to concentrate. Next, what is the average value of freewheeling diode current? What is the average value of freewheeling diode current? Yes. Third formula. The average value of freewheeling, easy to write, sir. Average value of freewheeling diode, that is the diode current. The average value of freewheeling diode current equal to IL average into. Now tell me, during which time freewheeling diode is conducting? During switch on state or switch off state? During switch off state. That's why T off by T. Then what is IL average? IL average, that already you know. IL average into T off is 1 minus D into T na? By T. T cancel. Therefore, the average value of freewheeling diode current equal to IL average into 1 minus T. IL average into 1 minus T. The average value of freewheeling diode current equal to IL average into 1 minus T. This is the average value of freewheeling current. Clear? Next. What is the RMS value of freewheeling diode current? Very, very important gunshot formula. What is the RMS value of freewheeling diode current? The RMS value of freewheeling. RMS is, you take the IL RMS into, RMS is square root. I told so many times in the rectifiers. Wherever the RMS, you take continuous mode, square root T R by T. Then by simplifying this, IL RMS into square root 1 minus T. But you have the doubt, sir. I know the IL average. What is IL average? I naught. IL average equal to I naught. What is IL average? Equal to I naught. But what is IL RMS? There is derivation is there. I'm not giving derivation directly. I'm writing IL RMS equal to IL average square plus delta IL by 2 root 3 whole square. Still now, based on this formula, no question. Only question repeated in different competitive exam, even GATE exam also, only average diode current. But our RMS diode current is not asked still now in any competitive exam. If it is asked, you're ready to answer. IL average square plus delta L. Delta L is peak to peak inductor ripple current, sir. What do you mean by peak to peak inductor ripple current? Listen, sir. This is called delta L. The current is changing between minima and maxima. Between minima and maxima. This is called delta L. This current is changing between minima and maxima. This is called delta L. What is delta L here? IL max minus IL minimum. Maximum current minus minimum. Later on I will give in detail expressions also. This is the peak to peak inductor ripple current IL max minus IL minimum. Next. This I given third formula and fourth formula. The fifth one. What is the peak voltage across the switch? Sometimes it is asking that what is the voltage across the switch? I'm asking one question, students. Switch blocks the voltage during on state or off state. Switch blocks the voltage during on state or off state. During off state. If the switch is off, then only it blocks. Na? If switch is off, diode is on. Then what is the maximum voltage across this switch? What is the maximum voltage across this switch? Only this voltage only. Na? This voltage only will appear across the switch. That's why this question is also there in competitive exam. What is the peak voltage across the switch in a buck regulator? The peak voltage across the switch is nothing but a Vs only. Very simple formulas, no doubt at all. Very simple formulas we can get. Except inductor and capacitor formulas, remaining formulas are very easy. But you have to practice and apply these formulas solving of the problems. By using all these formulas, I will solve one problem. Like that, you have to practice any problem. What is the average source current? Yes, friends. There is one procedure is there to find the average source current in all the choppers. Step down, step up, or up down. You follow the same procedure. How to find the average source current? To find the average source current, let assume lossless chopper. This is the assumption. With this assumption only, you can find the average source current for any chopper. Let assume lossless chopper. Let assume lossless chopper. If it is lossless chopper, input power equal to output power source. If it is a lossless chopper, input power equal to output power. Input power equal to output. You take input power is Vs into Is. Output power is V naught into I naught. What is V naught? dVs into I naught. V naught equal dVs. This Vs cancel. What is the average source current? Very, very important 5-star gunshot formula. So many times in competitive exam it is asked. What is the average source current in a step down chopper? The average source current in a step down chopper Is equal to di. The average source current equal to Is. Don't confuse same notation I used in rectifiers where I take an RMS notation, but it is average. DC na is average source current. The average source current equal to di. The average source current equal to di. That you have to. The average source current is di naught. But one observation here, the source and switch is series. In this chopper, source and switch is series. That's the reason why the average switch current and average source currents are same here. No, in this chopper only, in this chopper, source and switch is series. That's why average source current equal to average switch current. Average switch current. Both are same. That is equal to di. But here I have to give one note points. Very important observation. Listen. What is V naught equal to? Output equal dVs. What is I naught equal to? Is by d. That is Is equal di naught. Na? If Is equal di naught, what is I naught equal to Is by d? I naught equal to Is by d. V naught equal to dVs. V naught equal dVs. You substitute any value of for 0 less than d less than 1. For 0 less than d less than 1, we can get V naught less than Vs. But I naught greater than Is. Why? Here Vs is multiplied by d, but here Is is divided by d na. That's why for any value of duty cycle in between 0 to 1, we can get V naught less than Vs, I naught greater than Is. That means output voltages are decreasing, but output current is increasing for different values of duty cycle. Voltage reducing, currents increasing. This type of relations where you see, in which circuit you see, voltages are reducing, currents are increasing. You know, in the transformers, in transformers, voltage ratios and current ratios directly proportional or inversely proportional. You know this one na? E2 by E1 equal to N2
Inverse proportion, sir.
I1 by I2. Inversely proportional na? This is happening same here. Voltage reducing, current increasing. Voltage reducing, current increasing means this is step down or step up? Step down. That's why a step down chopper is a DC equivalent of step down transformer. A step down chopper is a why? Voltage reducing, current increasing, just like a transformer. A step down chopper is a A step down chopper is a DC equivalent of step down transformer. DC equivalent of step down transformer. Step down transformer. That you have to consider. These are the what exactly peak voltage across the switch, what is the average source current, why it is a DC equivalent of step down transformer, because voltage reducing, current increase. Next, we have to derive the peak to peak inductor ripple current. Peak to peak inductor ripple current. Yes, friends. I told already, this is IL minima, minimum inductor current. This is IL maxima, maximum inductor current. And this is IL average, average inductor current. The current is changing between minima and maximum. The current is changing between minima and maximum. Chopper on, chopper off. Yeah, this is chopper off. The current is changing between minima and maximum. This during this time, chopper is on. During this time, chopper is off. Again, chopper is on. This is chopper on. This is chopper off. Again, chopper on. Current changing between minima and maximum. Then what the peak to peak inductor ripple current? The peak to peak inductor ripple current. Inductor ripple. The peak to peak inductor ripple current delta IL equal to IL max minus IL min. IL min. That is IL maximum. This is called peak to peak inductor ripple current. Maximum current minus minimum current. This is delta IL. Peak to peak inductor ripple. But I have to derive this formula in terms of the duty cycle and supply voltage, all this. For that, you take chopper is on or chopper is off switch. Any thing you take, either chopper on state or off state, you have to take. I'm taking during chopper on. During chopper on. During chopper on. During chopper on, what is VL on? VL on equal to Vs minus V0. I already know this, in the KVL, you know this formula. Starting at N L into DL, DI by dt, DIL by dt. L into DIL by dt. During chopper is on, how the current is changing? Current is changing from minima to maximum. Minima to maximum. Minima to maximum. Change in current, I will write IL max minus IL minima. IL max minus IL minima by this. dt. dt is during which time this? This is during on time. Chopper on time. No? Time is during on time. Then Vs minus V0 equal to L into what is IL max minus IL minima? Delta L. L into delta L. This is during chopper on I take. By considering chopper off also, you can derive same formula. T on equal to dt. I am writing T on equal to dt. T on is dt na. I think all of you know this na. dt. Then Vs minus. What is V naught? You write dVs equal to L into delta L by dt. Take the Vs is common. 1 minus d into L into delta L by dt. From this, you calculate what the delta L, friends. Delta L equal to d into 1 minus d into, you bring this side, dt this side, into Vs into t by L. Then what is the delta L? Delta L equal d into 1 minus d into Vs by, I am writing t is 1 by Fl. Very, very important. 5-star gunshot form. So many times in all the competitive exam, question is there. Then therefore, in buck regulator or step down chopper, Therefore, in buck regulator or step down choke, this formula you have to remember, fine formula. In buck regulator or step down chopper. Step down choppers. What is the peak to peak inductor ripple current? Direct formulas also asking in compute exam. Peak to peak inductor ripple current. Peak to peak inductor ripple current. Peak to peak inductor ripple current equal to, that is delta L equal to, what is the formula? Ready for, remember this formula? Who are waiting for final formula? D into 1 minus D into Vs by Fl. D into 1 minus D into Vs by Fl. F into L. D into 1 minus D into Vs by Fl. F into. This is the peak to peak inductor ripple current. Now, this one point. Where these ripples are maximum. This is ripple currents. Ripples means it is not a constant. There is some change in current, minima to maximum. Instead of straight like this, we are getting, there is slight change from minima to maximum. The currents are changing. That is nothing but a ripples. Now the question is, for what value of duty cycle these ripples are maximum? To find the condition for maximum ripple currents, you have to differentiate this and equate to zero. To get condition for maximum ripple current. Maximum ripple current. What do you write? Differentiate with respect to duty cycle and equate to zero. You differentiate this and equate to zero. During differentiation, FL Vs is constant. Now, can I do like this? D by dt of D into 1 minus D into Vs by Fl equal to 0. I am differentiating D by dt of D square D minus D square equal to 0. You differentiate 1 minus 2D equal to 0. Then D equal to 0.5. Very important who are preparing for PSU's point of view, state government jobs point of view also it is important. In buck regulator, at what duty cycle ripples are maximum? 0.5. At what duty cycle? Therefore, in buck regulator or step down chopper, in buck regulator or step down chopper, ripples are maximum. Ripples are maximum. Come on, students. Ripples are maximum. Direct question is asked. Even in ESC exam also this question is there. Ripples are maximum. Repeated question in different competitive exam. At duty cycle equal to 0.5. At what duty cycle ripples are maximum? At duty cycle equal to 0.5. Okay. This is one formula. This is one condition. Now the question is, okay, sir, you are telling that ripples are maximum at duty cycle 0.5. What is that maximum value of ripple? How to get maximum value of ripple? You substitute D equal to 0.5 here. We can get the expression for maximum value of ripple current. Then how to get a maximum value of ripple? The maximum ripple current. Maximum ripple current. Maximum ripple. The maximum ripple current delta L max equal to delta. Substitute D equal to 0.5 here, friends. 0.5, 0.5, 0.25. 0.25 is 1 by 4. That is Vs by 4F. What is the value of maximum ripple current? The value of maximum ripple current equal to Vs by 4Fl. How I got this one? How I got this one? If you want any doubt, how to get the maximum ripple current? To get maximum ripple current, substitute T equal to 0.5 in delta I. In delta I. Then what is the delta L max you can get? This delta L max equal to Vs by 4F. We can get a Vs by 4M. That is the maximum ripple current. This is also important. That formulas also important. Up to now, I explained how many formulas? 7 formulas. 7 formulas that I give. Still nearly 10 or 12 formulas. But don't think, sir, this much number of formulas, how we have to. Sir, it is very simple formulas. Just practice each formula 2 or 3 times. You can easily remember any formula. Okay, maximum for you, only for gate only discontinuous mode is important. Remaining compute exam not important, discontinuous mode. Maximum these formulas only important. At the end, I will give some formulas for discontinuous mode. This all these are continuous mode of operation. This is the delta L max equal to Vs by 4. Still, I have to explain what the maximum inductor current, what the minimum inductor current, what the peak current through the switch. Every formula important. What the critical inductance? This is very important. What is the concept of critical inductance? What is the peak to peak capacitor? What is the RMS voltage? What is the form factor? What is the ripple factor? And what is the peak to peak capacitor ripple voltage? Maximum and minimum voltage across the capacitor, critical capacitance, average voltage across the load in practical case, and discontinuous mode analysis. This I have to give. These are the summary formulas. This about the today session. Tomorrow will continue. Tomorrow this buck regulator will complete and we will solve the problems on buck regulator also. Any doubts, friends?
Sir, one doubt, sir.
Please tell me.
Sir, kindly say what is the difference between chopper and regulator?
Generally, a chopper is nothing but there is no any filter representation. So in this circuit, I represented L and C now. LC.
Yes, sir.
You seen in the circuit now LC.
Sir,
That
yes, sir.
L is the filter inductor, C is the filter capacitor. Without L and C, that is the chopper. If you take L and C consideration, that is the filter. Sorry, that is the regulator.
Okay, sir. Okay, sir. Thank you, sir.
But point you have to remember, for this, it may be regulator is given or chopper is given. Formulas are same, no doubt at all. But extra filters we are using, that's why it is taking as a regulator.
Okay, sir. Okay, sir. Thank you, sir.
Thank you. You please collect this PPT, my Telegram channel. Thank you.